Good afternoon, everybody. Welcome to our next session here. Molly Akmanalp is going to be speaking on library UX, using abstraction towards friendlier APIs. Let's give him a big hand here.
All right, thank you. Okay, I was going to ask if anyone can hear me at the back, but I think I can sort of hear my voice booming. Okay, so who here has had to write code that other people consume and use? Okay, good. That's what I was hoping for. All right, so before we get started, the slides are online. I tend to go through slides quickly, so if you want to follow through with stuff, also all the links to things that I reference are all here, bit.ly/abstraction talk, and also message me on Twitter if you want. Okay, so I want to talk about this idea of user experience, and it's sort of this general concept of how does this thing make me feel when I use it, right? Does it make me feel excited or frustrated or what? And traditionally, product-based companies think about UX a lot, right? So you get your shiny new Apple product, and they've sort of thought about everything that happens when you open up the package, and you see the shiny thing for the first time through the time that you chuck the device away, right? So that's sort of one aspect of it. And another sort of slightly overlapping aspect is usability, right? So the idea of how easy and how intuitive is it for me to learn and use this thing, right? And I think both of these things come late into the consideration of the design of libraries, if ever at all. And so what really sort of nailed this down for me, this idea, was this talk by this guy called Kenneth Reitz. And so in his talk, he's talking about this example where he's trying to query the GitHub API, right? And so this is what he ends up with, where all he's trying to do is send an HTTP request to an endpoint that is password protected, so he has to somehow get through the password. And just the mechanics of this is sort of crazy, right? He has to create a HTTP password manager with default realm, and he has to add a password and create an auth handler. He needs to build an opener, install opener, URL open, and then finally you get the thing, right? And then there's another step to it where he has to create a custom class to handle some sort of edge case, right? And this isn't something that should be sort of simple. And so at the end of the talk, this is sort of what he arrives at, right? So this is sort of his library that does pretty much exactly the same thing, but you have 4 lines of code, and for the most part, they seem to make sense, right? Request.get, you pass it a URL, and then you pass it a username and password, a credential pair, and you're done. So this is a drastically different experience, right? It's just in terms of how it feels to do this versus how it feels to do the previous thing. And so, at this point, you're probably looking at this, and some of you are why is URL-lib so terrible? And then some of you are probably sort of mad at me at picking at URL-lib too. And so don't jump to conclusions yet, and hold that thought, because I have an alternate theory of sort of why this mismatch exists. So the moral of the talk that Kenneth Reitz was giving was sort of this idea that libraries can be for humans, right? So in the end, code is for people, right? Machines use it, but in the end, we end up having to create the code in the first place, which is sort of the work-intensive part. And people have feelings, right? So why care about how your users feel? Why care about UX in the first place? Part of it is that you're probably a nice person, but aside from that, there's many other reasons, right? So okay, first big reason, good UX reduces mistakes, right? So if we go back and look at this example, if you look at how many lines of code there are, okay, so let's focus on some specific bits. Right, so this bit over here where you call this add password function, and there's 4 different parameters that you're passing in. But when I'm writing this code, what are the chances that I'm going to screw the ordering up, right? Or screw the typing up, or get some parameter wrong, right? Pretty high. I'm probably going to mess that up, right? So here's another thing, right? So build opener, install opener. So it's verb _ noun. Cool. And then over here, you have noun verb, right? And so, is it one or the other? Am I going to remember under which conditions it's one and which conditions it's other, right? So not having these sort of these inconsistencies like reduces mistakes, right? Okay, so another aspect. Good UX minimizes distractions, right? So chances are when I'm trying to solve a problem, when I'm doing something, I don't really care about your library's internal implementation details because it's not really about you as a library author or me, whoever, right? It's about me and what I'm trying to do, right? Like the library in the end is a means to an end. And so like all I'm trying to do is to do my job, and I want my tools to sort of get out of my way for the most part. Just like I want them to help me do things, not I don't want to spend time trying to get them to do things. Okay. Another thing is that good UX makes complex tasks routine, right? So there's this idea of batteries included in the Python world, right? And it's this feeling of this feeling that I have many tools in my toolbox, right? And I don't have to spend a lot of time doing this sort of like song and dance around creating a boilerplate and remembering all these like incantations that I have to like sort of repeat back perfectly to get things to work, right? And this is a really powerful feeling because I can sit in front of a terminal or a Jupyter notebook or whatever, and I can pull in request, beautiful soup, pandas, I don't know, like Seaborn or something like that, and just be like, I'm gonna scrape a website and then like parse the data, do some transformation on the tables, and plot it, right? And this can happen within 10 minutes flat. And that's just an amazing feeling that enables you to do things versus like not do them in the first place at all because it just feels so hard to do them, right? So makes complex tasks routine. Okay, finally, good UX drives adoption, right? So here are a bunch of libraries that I think are famous for having sort of this nice user experience. And all these libraries have many other alternatives, right? There's many different things you could use instead of these, some of which are like built into Python even, right? So the barrier to entry there is really low. But people end up choosing these. And I think that this has a lot to do with the fact that people have spent time trying to get the user experience for these things right. Okay, so now, so the question is, how do we get to having better UX, right? And I want to switch gears to something that's seemingly unrelated, but is going to tie into things. Okay, so here is a webcomic I like called Abstruse Goose, and it's this sort of like comic about, this panel is about abstraction, and this is a programming conference, so I'm going to analyze this joke to death, and it's not going to be funny anymore. But the idea is that the universe is kind of like this like sort of this abstraction stack. It's like kind of like a stack of pancakes, and there are all these layers, right? And you start out at the top layer with like this video game about asteroids, and I have a spaceship, and I can press the keyboard and shoot some asteroids. And then below that you have like some C code, and below that you have some assembly language, and below that you have machine code, and below that you have like logic gates, ands, and ors circuitry. Below that you have like Maxwell's equations of whatever, and then below that you have sort of like the empty void of space, right? And so so here's my claim. My claim is that as programmers, we're primarily in the business of dealing with abstractions, right? This is sort of like the world that we live in, and but we're sort of like we live unaware of the fact that we're creating and using these abstractions all the time. And we would do well to pay more attention to them. Right? So here we are as Python programmers. So we're not up at the level of asteroids and stuff, but we're not, we're definitely higher above than the C world, right? We fall somewhere in the middle, and Python within itself has all these like different layers. But so here's my theory of why I think a lot of us like Python. Is because it's like a high-level enough abstraction that it can sort of solve goal-driven needs, right? So I need to do something, and I can do it in Python without spending too much effort. Versus like imagine doing something that I previously described in like C, right? Or like assembly language. I'm going to scrape websites in assembly language, right? So there's definitely like a mismatch there. Okay, but but what is abstraction really, right? So abstraction is this, it's about hiding details in a controlled way, right? So I want to hide details, but why do I want to do that? Like, why do I want to hide things from the user? And so one reason is hiding details helps reduce mistakes, right? So if we go back to the request example, there's only like, 5 lines of code, right? And its request is highly abstracted, and the less code you have, the less chance you'll get things wrong, right? So not too controversial. So hiding details also makes complex tasks routine, right? So the cool thing is that I don't have to understand like assembly language or Maxwell's equations to be able to make a video game about asteroids, right? So it helps us reason about complex ideas, right? So here's another webcomic that I really like. It's part of this like larger comic, and like this like the context is that there's this sort of ridiculous argument about my editor's better, and like this other person's like, no, my editor's better, right? And this person's like, excuse me, but real programmers use butterflies, and they let the butterflies fly, which like the ripples of their wings cause like these eddy currents that cause cosmic rays to filter through and like hit my hard drive to edit like some bits on the hard drive, right? And so I like this because it makes fun of the real programmer trope, but also I like this because of the sort of like the ridiculous idea of butterfly-based like disk I/O. But like imagine that we had that world, right? And imagine, so what would I be thinking about when I'm writing code most of the time? And chances are I'd be spending most of my time thinking about like the butterflies and how I'm going to get the butterflies to do the right thing, right? And not like thinking about files and like lines and editing files, right? And so the sort of like my horizon of what I think I can do with this is like much lower, because once I start thinking about files, then I can think about folders and file systems and structures and all this stuff. But here I'm stuck thinking about butterflies, right? So makes complex tasks simple. Okay. Another thing is that hiding details provides a stable interface, right? So if I have details hidden, if things are abstracted, then changes under the hood are zero cost, right? So I can change the guts of what I'm doing, and the user doesn't have to care about this at all, right? And as a benefit, testing is easier. Okay, so here's a claim. You'll notice that I mentioned a lot of the same things when I was talking about good UX and when I was talking about sort of like the benefits of abstraction. And my claim is that these two things are aligned, right? They're not exactly the same thing, but I think thinking about this improves UX greatly, right? So now let's talk about abstraction in Python, right? So what tools do we have in Python to do this stuff, right? Okay, so the simplest thing we have are functions, right? So let's say we have a variable a, right? And it has a 4 by 3, like sort of array of arrays, or a table if you want to call it, right? And I can use NumPy, right? I can call np.resize, and I can pass it like 2,6, and it'll reshape the entire structure for me, right? And I could probably write some code to do this, but there's probably like a lot of weird edge cases, and like the NumPy people probably committed a lot of blasphemies in the name of speed, right? And I don't have to think about that myself, right? It's that easy. So, the second option is classes, right? And so, here's another tool, SQL Alchemy, right, where you can define these classes, and you can say, my class, I have a user class, and it has a name and a dessert, because, I don't know, people like dessert, or something like that, right? And it's sort of behind the scenes, there's all this magic that, goes and creates these like tables in a database that sort of maps to the structure, right? So I can do stuff like, I can sort of create something that sort of represents me, and I like pumpkin pie. And then I can sort of like play around with this, right? So I can say Molly.name, I can change my name to Molly2, I can save this object, right? And so what's nice about this is that classes make state explicit and organized, right? And so the idea is that you want to be able to group state and behavior together, which results in something that's like a little bit more cleaner, perhaps. And the idea is that the behavior changes depending on what state the object contains. So 2 separate tools. Okay, so what are some pitfalls? Some pitfalls, so with great power comes great responsibility, and so there's a cost to building a lot of layers of abstractions, right? So one thing that happens is leaky abstractions. So leaky abstractions when you're trying to hide details, but the details themselves are sort of refusing to be hidden. So here's an example. Let's say I make a table, right? I have this for loop that creates a 1,000 by 1,000 table. It looks a little bit like this. 1,000 by 1,000 is kind of big, so I put a lot of dots in there, but that's the general idea. And let's say I want to loop through this table and like do a bunch of stuff, right? So here's one way to do it. So I have like 2 for loops, for I, and then for j, and then I'm going to sort of access each element, right? And I can use the IPython's fancy time it function to see like how long this takes. And apparently this takes 163 milliseconds, right? So now, the other thing that I can do is, what if I switch these 2 things, right? So this used to say j and I, and now it says I and j. And then now it seems to take 97 milliseconds, right? So what the hell? How come it's like almost twice as fast, right? There's definitely something weird going on here. OK, but what's actually going on? So the first time around, when you're looping through, you're looping in this direction, right? So you loop the first time, and you're sort of going from 2 all the way to 6, right? And you do the same thing, and you do the same thing, and you do the same thing, and you'll see that it sort of goes towards the grain of the table, where like everything that I'm scanning is like contiguous lists, right? And then if I do the other thing, when I switch the I and j variables, you start scanning this way. And what that does is now you're hopping through different lists as you're scanning through, and all the whole time you're hopping through, right? And turns out that has implications about like how processors work, and accessing random areas of memory turns out to be slow, right? But the idea is that the abstraction is now leaky, right? Theoretically, you have loops, and it shouldn't care about which way you loop through things, but we find out that sometimes it does matter, right? So there's this law of leaky abstractions, right? The idea is that abstractions might have leaks in them and might fail to hide details, right? But sometimes there's an acceptable compromise. OK, so now, OK, oops, sorry. So another pitfall is under abstraction, right? So this is like not that hard to spot. It's pretty common. Like you'll see sort of like the guts of your code everywhere. There's like many different variables and control flow and like sort of really nested if statements, and everything's sort of hard to understand. And the telltale sign is that people, even with domain knowledge, right, people who are supposed to understand the subject of your code can't really understand what's going on, right? Okay, the opposite spectrum is over abstraction, right? And so this has like a bunch of different implications. So you want to watch out for, okay, for example, one thing is coupling, right? So if you want to change one thing, then sometimes you end up having to change many different things in many different places, right? So this is sort of one potential issue. Another potential issue is cohesion, right? So if you have one thing that tries to do too many things at the same time, right? And those things aren't necessarily related to each other, but you've sort of stuffed them all into one module or one object. And so now it's like sort of, regardless of what task you have to do, you have to sort of pull in this generic object, and it's like annoying. So OK, so we want to decide on the level of abstraction, right? You're building a shiny new app, and you're trying to figure out how to structure your stack of abstractions, right? And so let's go back to this model. And let's simplify it a little, right? So we have all these like generic layers. So this is one option for what my app might look like. So here's another option where I have only one layer, right? And I have, I could even have even more layers, right? So there's this sort of fundamental question of how many layers should I even have in the first place? And also, like, what should the layers themselves be, right? It's like sort of a non-trivial question. Are the layers sort of, can they be grouped meaningfully? Are they related at all? If they're related, then, can I do away with some of them and still preserve that grouping? It's like, there's clearly a lot of decisions to make. So here's my advice. There's a product manager saying that's the idea of write the press release first, right? OK, like think about it. Like library allows developers to compose queries programmatically, right? That's like SQL alchemy, and that like hopefully makes you pretty happy. Or like tired of writing repetitive CRUD web app code, like no more, and like that's like Django. And then machine learning in 3 lines of code, right? That's like scikit-learn, right? And I don't know, like data munging, no problem. And by this point, like I have tears of joy in my eyes. But the idea is that like this forces you to think about like in the end what I'm trying to get to by building this thing, right? And so then your decisions that you're making about your API should sort of like flow backwards to that, from that. So OK, second thing that's helpful is to sort of imagine that you had this library and write some code as if you're using it, right? So it's like this idea that maybe you want to play pretend a little bit and sort of try to drill down into what would it be like to use this library. And that's really nice because it forces you to not think about technical constraints first, and again, forces you to think about sort of like the final end user experience. It forces you to be specific about that thinking instead of being like really, really generic. You know, in some circles, this is called like contract first development. And okay, another thing that's helpful is like now that you have these sort of imaginary code samples, try to rewrite them with like existing libraries and see like, you know, have other people tackled similar problems, or like does my library provide a significant improvement, right? Okay. Other things, you know, what does this abstraction cost me, right? You know, am I falling into any of the pitfalls, right? So what's the potential surface area of this, right? You know, maybe I'm gonna run into some coupling, but it's like in a tiny little bit, so you know, like I don't care about that much. Or, you know, what's the potential cost of unchanging or undoing this abstraction? You know, sometimes, you know, maybe you're gonna find that you're wrong, and is it gonna be horrible to try to undo this, right? Or, you know, how likely is this thing to change, right? You know, maybe you don't want to generalize your code for, you know, things in the future that are never going to happen, right? Like if I'm going to make a game, like a chess game thing, then I don't, you know, do I really have to create like an n-dimensional chessboard class, or, you know, like is the regular old two-dimensional thing fine, right? Probably. So, and finally, it's like sort of a more general question of like, how does this even benefit the user, right? Does it sort of reduce cognitive load and complexity? Does it make my code shorter? You know, and many things fall under this. So, okay, one thing that I want to talk about is this idea of dry, right? Don't repeat yourself. So this is something that we've all, you know, I think it's like a commonly mentioned thing, and we hear about it a lot. And, you know, it's this idea that if you see yourself repeating similar bits of code over and over and again, then maybe you want to like sort of pull that out into a function or a class, right? And this feels good because it's like, you know, it's a thing you can do, and like everything looks a lot cleaner, right, and better. But then the counterpoint to this is that like inherently what you're doing is you're adding layers, right? And I didn't make this up, someone cleverer than me did. But, you know, that's not always a bad thing, right? Sometimes it's a good thing. But you know, if you're going to create like this wide-ranging structure, you're going to do this refactor that touches everything, then your potential risk is really high. So you know, it's worth thinking about the potential costs of this, right? And so one tool we have to tackle this is like this idea of incremental architecture, right? Like I gave you all these tips about like, you know, what you could do to sort of like build these levels of abstraction, but like really what's the hurry, right? So good architecture and good abstraction decisions follow from domain knowledge, right? Like if you understand your problem really well and what your users are trying to do really well, then chances are you're going to build the structures that are helpful. But you know, the more time you spend on a project, the more domain knowledge you accrue. And like ergo, you know, the earlier on in the project, the less domain knowledge you probably have, right? And as you go further, you like learn more and more. And so, you know, trying at least to have some restraint in terms of building less structure up front is helpful because it sort of protects you against these like future potential problems, right? You'll eventually find perhaps that you were wrong or off about what you're building in the first place, and you'll change direction completely. And it'll be easier when you have too little structure rather than too much structure. You know, again, there's a balance as with everything. But not fixing problems before you have them and like adding things incrementally is great. Okay, so here are some tricks of the trade. So abstraction doesn't mean building a wall, right? You want your layers to be like a hood, and I want to like be able to pop open the hood, right? So it's like a little bit like this, and then maybe I want this to be like a little bit see-through. Right, so here's an example from Flask that does this, right? So Flask is like a library that lets you create, you know, like web APIs or apps or whatever. So here's a function yum that returns donuts, and if I go to mywebsite.com/dessert, it's going to return donuts. Right, so under the hood, this little root bit uses a library called workzug, right? And so if I decompose what this function is doing, it's actually doing something like this. It's saying app.addURL rule, and it's saying if I hit the slash thing, then call the dessert function, and I'm going to call this dessert, right? And so if you look at what addURL rule is doing, it's sort of creating a new rule class object, which turns out is from the worksug library, right? And it sort of assigns things to self.url map. So this is cool because now I know that if I look in self.url map, I have access to the lower layer, even though most of the time I don't have to touch it. If I do have to touch it, it's there, right? Another cool thing is that it allows you to sort of like pass through these options to the lower layer, right? So the idea is it's like sort of opening the layer below to access, right? Request does something very similar with urllib3, where like in a lot of cases you can sort of like pass through urllib3 objects and sort of like poke at the layer below if you need to. So another trick is that more layers can sometimes make things cleaner, right? It's not always true, but when it works to great effect, right? So, when you have like a library and you have all these layers of abstraction, big question, like which layers should the end user know about, right? And usually the traditional answer is like this, right? So the outer layers for the user and the inner layers are for us, right? But like, what if there are meaningful groupings between the layers, right? And some of the lower layers are also potentially familiar, right? So then why not expose each of these lower layers also individually as full-fledged APIs that we fully support, right? And so this happens very often, actually, in the Python world at least. So Bokeh is a library for interactive online visualization, and they do exactly this, right? So they have Bokeh charts, which is like charts like, I don't know, scatter plots, histograms, all this stuff, right? Really sort of generic high-level charts. And then they have like Bokeh glyphs, which is just like doesn't know anything about charts, but knows about like lines and circles and dots and all this stuff, right? And then there's like Bokeh.js, which is sort of like the layer below that, which is like the JavaScript layer, right? And so, all these layers are fully supported, and I can move up and down as much as I need, right? So all these have different levels of configurability and effort, and they choose to expose all three, right? Another one is SQL Alchemy ORM, and SQL Alchemy Core, right? So SQL Alchemy is a database toolkit, and there's like sort of different layers at which you can tackle things depending on the complexity of your problem, right? Another one is sort of matplotlib and like all these charting libraries like Seaborn or ggplot. What's interesting about this one is that there's sort of different authors between these libraries, but there's this sort of mutually symbiotic interplay going on, right? And so I want to conclude with this thought that these different authors chose different levels of abstraction for a specific reason, right? So here's my big claim. My claim is that the right level of abstraction is audience-specific, right? So if we go back to the requests and urllib2 example, like, OK, on the left, you see requests, a few lines of code, and on the right, it's like a bajillion lines of code. So is urllib2 under-abstracted in this situation, right? But, urllib might be the wrong level for you, but it might be the right level for people who are developing libraries around HTTP. And so, maybe it's OK that some APIs are closer to the machine and some APIs are closer to the human, and perhaps we need both of these, right? And so all these libraries that are for humans libraries, they add these layers that we didn't know that we were missing. This is my theory. We were sorely lacking these layers, and once people created them, it was like, oh my God, this is the best thing ever, right? This is saving me so much time. And so in the end, abstraction isn't really a goal, it's a tool, right? It can be used for good and bad, and it's everywhere. And it's a tool that we, I think, inadvertently use. And so hopefully you start seeing it everywhere and sort of make the UX of everything better. And hearing from you makes me happy. So that's it. Thank you. Over. Thank you.
Great. Thanks, Melly. I'm afraid we really don't have time for questions here, but perhaps you can catch him out in the hall here or later in the conference.
First big reason, good UX reduces mistakes, right? So if we go back and look at this example, if you look at how many lines of code there are, OK, so let's focus on some specific bits. Right, so this bit over here where you call this add password function, and there's 4 different parameters that you're passing in. But when I'm writing this code, what are the chances that I'm going to screw the ordering up, right? Or screw the typing up, or get some parameter wrong, right? Pretty high. I'm probably going to mess that up, right? So here's another thing, right? So build opener, install opener. So it's verb _ noun. Cool. And then over here, you have noun verb, right? And so, is it one or the other? Like, am I going to remember under which conditions it's one and which conditions it's other, right? So not having these sort of these inconsistencies like reduces mistakes, right? Okay, so another aspect. Good UX minimizes distractions, right? So chances are when I'm trying to solve a problem, when I'm doing something, I don't really care about your library's internal implementation details because it's not really about you as a library author or me, whoever, right? It's about
Good afternoon, everybody. Welcome to our next session here. Molly Akmanalp is going to be speaking on library UX, the using abstraction towards friendlier APIs. Let's give him a big hand here.
All right, thank you. Okay, I was going to ask if anyone can hear me at the back, but I think I can sort of hear my voice booming. Okay, so who here has had to write code? Get, you pass it a URL, and then you pass it a username and password, like a credential pair, and you're done. So this is a drastically different experience, right? It's like just in terms of how it feels to do this versus how it feels to do the previous thing. And so, at this point, you're probably looking at this, and some of you are like, why is URL-lib so terrible? And then, like, some of you are probably sort of mad at me at picking at URL-lib too. And so, like, don't jump to conclusions yet, and hold that thought, because I have an alternate theory of sort of why this mismatch exists. So the moral of the talk that Kenneth Reitz was giving was sort of this idea that libraries can be for humans, right? So in the end, code is for people, right? Machines use it, but in the end, we end up having to create the code in the first place, which is sort of like the work-intensive part. And people have feelings, right? So why care about how your users feel? Like, why care about UX in the first place? Like, part of it is that you're probably a nice person, but aside from that, there's like many other reasons, right? So okay, things come late into the consideration of like the design of libraries, if ever at all. And so what really sort of nailed this down for me, this idea, was this talk by this guy called Kenneth Reitz. And so in his talk, he's talking about this example where he's trying to query the GitHub API, right? And so this is what he ends up with, where like all he's trying to do is send an HTTP request to an endpoint that is like password protected, so he has to somehow get through the password. And just the mechanics of this is sort of crazy, right? He has to create like a HTTP password manager with default realm, and he has to add a password and create an auth handler. He needs to build an opener, like install opener, URL open, and then like finally you get the thing. Right? And then there's like another step to it where he has to create a custom class to handle some sort of edge case, right? And it's like, this isn't like something that should be sort of simple. And so at the end of the talk, this is sort of what he arrives at, right? So this is sort of his library that does pretty much exactly the same thing, but you have 4 lines of code, and for the most part, they seem to make sense, right? Requests that other people consume and use. Okay, good. That's what I was hoping for. All right. So before we get started, the slides are online. I tend to like go through slides quickly, so if you want to follow through with stuff, like also all the links to things that I reference are all here, bit.ly/abstraction talk, and also message me on Twitter if you want. Okay, so I want to talk about this idea of user experience, and it's sort of this general concept of how does this thing make me feel when I use it, right? Does it make me feel excited or frustrated or what? And traditionally, product-based companies think about UX a lot, right? So like, you get your shiny new Apple product, and they've like sort of thought about everything that happens when you open up the package and you see the shiny thing for the first time through like the time that you chuck the device away, right? So that's sort of one aspect of it. And another sort of slightly overlapping aspect is usability, right? So the idea of how easy and how intuitive is it for me to like learn and use this thing, right? And I think both of these